find domain. When you sketch a linear quadratic graph, like I just tell you y equals x plus 1, y equals x squared minus x plus 2, like you assume what? You assume the domains are. When we haven't talked about the domain, we assume domains are. But in some case, for example, when I say square root x, what do you assume your domain will be for this one? Like, well, we haven't learned what is domain. What you can put into square root? Positive and zero, right? So there are some functions without any restriction. For example, linear, quadratic, there's no restrictions at all. Like I can just take any value, sub into the function, no problem. But say y equals to square root x, even though we haven't learned domain, we haven't learned the graph, you know the x value can't be negative because you can't put negative number into square root. So there are some functions with restrictions itself. And so with restrictions itself, there are three type of functions with restrictions. So I'll just like this is a very detailed one. So I will just do like a general one for you. So the first type with restrictions is has x on denominator. Okay, like fractions, or say let's say we have fractions. Okay, we have fraction expression. So when you have a function, you have fraction expression like y equals to something over something, and then the denominator contains x. Okay, the denominator contains x. Okay, just my question is, what can't be the denominator? There's one thing can't be the denominator. 0. So what you need to think about is, I just let you denominator cannot equals to 0. Okay, so that's your domain. That's how you solve your domain. For example, y equals to 1 over x plus 1. Well, you know that's a hyperbola now. But say, for example, if I don't know it, I see there's a fractional expression. And I have x on the denominator. X plus 1 is the denominator. I have the x on the denominator. So if I want to solve my domain, like I want to solve this is called implied domain, or say maximum domain. Is the domain restricted by the function itself? It's not saying I restricted from -2 to 2. Like, is the function itself restricted the x value it can take? So in this case, if I want to solve the maximum domain this function can take, what all I need to do is just the denominator is not equals to 0. That's all I need to do. Because x plus 1 can't be 0, then anything else will be fine. Like, the denominator can be anything else but not 0. So in this case, we solve x not equals to -1. So x not equals to -1 will make the denominator equals to 0, but we don't want 0. So x can be anything else but not -1. So how I can write this expression, x belongs to what? Like into the notation we natural number is only 0, 1, 2, 3, 4, 5. Like I'll repeat myself again. X can be anything else but not -1. Like the only restriction is it can't be -1. Okay? Uh-huh. Okay. So what it can be? It can be anything else except. Yes. Okay. How to remove and okay. Let's say what's everything? Like what's the R? Okay. So R. I want to remove out what? I want to remove -1. So do you remember set difference? Yeah. So in the front set, but not in the second set. So -1 can't be there. So we get rid of -1 from the first set. Basically, we get rid of the thing from the second half. So I will get -1 out from R. So it can be the elements in the first set, but can't be the elements in the second set. So overall, it's just take out the -1 in this case. Okay, that's how we write the set notation here. Okay, that's fractional expression. Second one is with any root with an even number here, like square root. That means square root is one of it. Fourth root, sixth root, eighth root, like anything. Okay, so For even root, the thing inside must be what? Like what must be in square root? So what can't put into square root? Negative. So what can be in square root? Yes. Okay, 0 and positive. Okay, when you say positive or negative, it doesn't equal 0. So it can be 0 to positive, all the positive numbers. So in this case, if I have something like that, in this case, what I should do is I need to make inside to be greater or equals to 0. Well, what doesn't matter what's inside, like that expression needs to be greater or equals to 0, and solve for x. You can solve for x. Those x are the domain. Okay, those x are the domain. For example, let's say y equals to square root x minus 2. Well, we learned that's a square root function. Well, that's why I don't really like this order. I like to teach this first and go back to teach the graphs. It's much easier. Now I need to go back to the graphs again. So for this one, what I need to do, what kind of equation I need to set up? Like I want to solve the domain. What needs to be greater or equal to 0? X minus 2, the inside, whatever you put inside the square root, that needs to be greater or equals to 0. And when we solve it, x is greater or equals to 2. How I can write this expression, x belongs to what? As long as x is more than or equals to 2, that's fine. So, sorry? Too complex. Let's go a more straightforward way. 2 to what? Greater than 2 is 2 to what? Infinity. Good. So it's 2 to infinity. You can do multiple ways. It doesn't matter you go r except like from negative infinity to 2. Like, but sometimes it's too complex. Just go the more straightforward one. Which one is shorter and easy for you to write? You can write that. But you won't be marked wrong. Like even if you write that, you won't be marked wrong. That's still correct. But like for me, the most straightforward one will be greater or equals to 2 means you start from 2 until whatever, like positive infinity. So it's 2 to infinity to write this expression. Okay, that's the second one. We have a third one, but we can't really talk about the third one yet. Have you learned log in year 10? Not from the same school? Yes or no? Like, have you learned like a little bit about it? Yeah. Okay, log. Log at the base, right? Like, doesn't matter what's the base. What must be in the bracket? Like, do you remember that? What can be put into log? Trying to think about it. Log is the reverse of exponential, like a to the power 4. If you want to work out the power of 4 in the square for log. Hmm? No. It's not needs to be a square number. Think about positive and negative. Okay, I'll let you know. Like that needs to be positive, like not including 0. You can't put 0 into log. You don't have log a0. Like that doesn't exist. We'll talk about log in the second semester, so we'll learn log everything. But you just need to know the domain for log now. Like what can put into log. It doesn't matter what's the base. Well, your base needs to be positive as well. But it doesn't matter what's the base. What you put in the square, it still needs to be a positive number, not including 0. That's the difference between the square root and the log. Log must be greater than 0, and square root is greater equals to 0. And denominator is not equal to 0. For methods, there are only 3 restrictions. Okay, so like function by function nature, there's only 3 restrictions. One is the denominator, one is the even root, and one is the log. So for example, if I have log 2 4x minus 1, y equals to that. I want to solve the domain for this one. Let's go minus 2. Let's go that. So the bracket can only be positive. So it's minus 2x minus 1 must be positive. Well, I will flip it later, but I think I'll move the 1 first. And what I can divide. So I divide by -2, I have -1/2 on the side, and sign is to flip. Okay, less than that. Okay, so what's my, how can I write my domain? Like x needs to be less than -1/2. How I can write it? Start from where? -infinity. And finish at what kind of bracket? Round. Good. Okay, so x needs to be below, less than, so on the left hand side of -1/2. So if you draw on the number line, so it's this side. Okay, so it's that side. So it's from -infinity until the open circle -1/2, but with round bracket here. Okay, that's the only 3 things got restrictions by functions. When you do like implied domain, that's the only 3 things we have. Okay, there's only 3 things we need to consider. Do we have square root? Do we have log? Do we have denominator involve x? But they can get a combination of these 3. I can put a square root into a log. I can put square root and the denominator. Like I can combine 3 of it. Okay, let's see some examples here. It's not going to be that easy now. Okay, let's go one by one. Don't worry. Okay, look at the first one. Let's say that's A. Look at the first one. What do you care about? We see that what's involved, like square root, denominator, and log. Which one involved? Square root and denominator. Do I care about the numerator? No. Okay, it doesn't matter what's my numerator. I don't care about it. As long as there's no square root on the numerator, I don't care about it. So 2x, there's no restrictions for 2x. It's okay. 1 minus 5x needs to be what then in this case? Everyone agree? Because square originally square root can be greater or equals to 0. But because this time is on the denominator, so I can just go greater than 0 in this case. That's just 1 minus 5x greater than 0. Okay, I'll give you some time to work on it later. So that's just one inequality I need to solve for it. That's fine. Let's move on to B. You will solve that later. So let's move on to B. What you can see from B? Square root. And another one? One is square root. What's the other one? Well, I'll say false root like this. It's like square root, cube root, false, fifth, sixth, like we read like that. It's an even root, right? It's an even root. So what's the 2 equations you can give me? Well, there's 2 equations I can set up. Finish? Well, give me the original equation, like that's the answer. So what you solved? What are you trying to solve? 2x minus 5 needs to be what? Yep, greater or equals to 0. And how about from the second one, what you can see? 10 minus 3x. Yeah, you have solved 2 solutions here, right? Like one x is what and the other one x what. What you can do with the 2 solutions? Pick largest. Any other ideas? Like I can solve out x is what in this case, x is what in this case. I'll have 2 set of solutions. What we can do with that? What do you mean by largest? Like what's union? Union is everything in both sets. The intersects. Okay, so we need to find the intersections between those 2 sets because I need x to satisfy the first one. I also need x to satisfy the second one. So I need a common axis like to satisfy both of these equations. So I need the intersection, not the union. Because the intersection is satisfy the first and satisfy the second. Okay, solve that later and find intersections. For C, what kind of inequality you can give? You don't care about what's inside. Like, doesn't matter what's inside. Pick everything out and then make that greater or greater equal? Greater than 0. Okay, greater than 0. So same as the first one. Like, it's just inside is linear or inside is quadratic, but doesn't matter what's inside. You always make it equal, greater than 0. Well, if okay, that's C. Okay, let's look at D. D is another one. Let's look at D. What restrictions you can see from D? One by one, go one by one. How about the numerator? So from just look at the numerator, what you can tell me? Greater or greater equals to? Greater or equals to, because it's not on the numerator, I don't care, like it can be 0. Denominator 0 is not good, but like numerator 0, that's fine. I haven't checked it. Completely forget about it. Thank you. Okay. That's the first, okay, that's the first. And how about the second? Like what else you can see? That's the numerator is square root, and what you can see on the denominator. What do you need? How about the x minus 1? What's the requirement of x minus 1? Denominator. So what's the requirement of denominator? What can't be denominator? Let's ask this way. 0 can't be denominator. I don't need to be greater or less than. So I just need denominator not equals to 0. Okay, just not equals to. Okay, same. I need a common thing from the first one and the second one, because it's the same equation. I want that to be true on both top and bottom. So I need a common set from the first one and the second one. All right. I'll give you some time to solve this inequality and write that into set notation. Okay, spend your time, talk with your friend, but you need to get this done. Okay, so it's very important exercise. Solve the inequality first and then write the x into set notation for domain. Okay, I'll give you some time to do that. I'll just stop the recording here. So, okay, the first one is easy to solve. It's 1 greater than 5x, and then divide 5 on both sides. Is x less than 1 or 5? If you have problem of writing the set, I would recommend you draw things on the number line. So 1 or 5 is here, and x less than that is all the way that way. So x belongs to negative infinity to 1 or 5, exclusive, because it's an open circle. So from most left-hand side and to the right-hand side. Okay, that's the first one. I don't think we have problem with that one. I see most of you get that right. Okay, second one. Second one, solving the first. I have 2x greater equals to 5 and x greater equals to 5 over 2. So solving the second one is 10 greater equals to 3x and 10 over 3 greater equals to x. Yeah, same thing. If you can't see the common thing, I would recommend you to draw that on number line. Okay, 5 over 2 and 10 over 3, which one is larger? Which one's larger? 5 over 2, 10 over 3. Well, like 5 over 2 is 2 point something, 10 over 3 is 3 point something. Like, even though without changing it, I can still see it. 2.5 and 3.333. 10 divided by 3 is 3 something. So 5, you can do the common denominator, no problem for that. So 5 over 2 and 10 over 3. I'll use 2 different color pen if you still like think it's difficult. So from 5 to 2 to infinity, that's x greater equals to 5 on 2. And then when you go less than 10, x is less than 10 over 3. That's here, and then all the way to that side. You can easily see where's the common part. So the common part is just everything up to here and here. So it's in between. That's the common thing. Can both make first one true and second one true. So I will write x belongs to 5 over 2 to 10 over 3 inclusive, because there's no denominator involved. Okay, so that's just from A to B. And most of us get that right as well. Questions? Any questions? But if not, we can move to D first. Okay, solving like linear is easy. So we have 4x greater equals to -1 and x greater equals to -1/4. And for this one, it's 2x can't equals to 1. You solve inequality not equal as equal. Okay, so not equal as equal. How you solve equal, you solve not equal in the same way. So x is not equals to half. Again, we want to put that on number line to see it. So we have -1/4 and a half, like, you just need to get left and right correct. You don't need to worry about the scale. So x greater equals to -1/4. So it's all the way here. And x is not equals to half. Means we need to have an open circle here. Like I'm not going to take that value. So this value is included in the set of -1/4 to infinity. So I don't want it. So that's an open circle there. So if we want to get rid of one or two values from a set, so the way we should write it is -1/4 to infinity, except a half. So it's same as we take -1 out from R. So we do the same thing. We take a half out from -1/4 to infinity. Questions? Okay. I think we have big problems of solving inequalities for quadratic. Doesn't matter how many times I say it, you just don't sketch the graph. Okay. If next time I see some of you not sketching the graph and get the answer wrong, I think I'll ask you to draw 100 graphs for quadratic for me. Okay? That's a good thing to make sure you can sketch it. Say it again. Except linear inequality, any other inequality needs to use the graph to solve. You can't see it. You can't just use algebraic way to get it out. So you must use the graph to do it. So for this one, like I move everything to left hand side and make it greater than 0. So that's x plus 1 and x plus 6 if you factorize it greater than 0. Okay, why I also factorize it? Because I also solve. I also sketch it. I want to sketch it. So you will have x-intercept at -6 and -1. And you know it's a positive shape. Okay, it's a positive shape. I don't care about where's my y-axis, where's my y-intercept, like, doesn't matter. Just, I don't care about the turning point. Just sketch the x-axis and then draw the graph and make sure you know the x-intercept. That's it. You want greater than 0. So greater than 0 is this part of the graph and this part of the graph. So it's these areas, see those axes and these areas, so touching those axes. I guess it's those two red parts. So it's left hand side of -6 and right hand side of -1. And it's greater than 0, not equals to. So that's open circle here and that's open circle here. Because you can't take -6, you can't take -1. They will make the equation equals to 0. Okay, so I can write it in two different ways. The first one is straightforward. X belongs to -infinity to -6. Round bracket, okay, union -1 to infinity. Okay, so two different sets. Yeah, it's not joined together, so I can just write that. Another way I can write it is x belongs to R except -6 to -1, inclusive. Let's think about why I can write it this way. Why the first one is round bracket and the second one is square bracket? Do we want -1? Do we want -6? No. So that's why we want to exclude it from the second set, like from the first set. So that's why the second one got -6 and -1 inclusive. Okay, inclusive. So I don't want it. So that's why I put square bracket around that. Well, we don't really use this one. Like it's very confusing. Like I need to think, oh, square bracket or round bracket. So the first one is good enough to write and it's the common one to use. Okay, any questions? Any questions? All right, so except the homework you need to do on your textbook, I want to give you something a little bit extra. So you know all the graphs we sketch. I don't have time today to go through that, but I really want you to do this because I should actually teach this first and to draw the graph and talk about the domain and range together here. But I'm doing the reverse way. I can't do that. So I want you to write the domain and range in the proper set notation for all of the graphs you sketch. It won't take long. Okay, it's just take maybe 10 minutes if you know how to do it. Write the domain and range for all the graphs you have sketched. For example, the first one here, like for this one, I will write the domain. Well, I don't write domain. I write x belongs to r except -2 because domain can be anything but not the vertical asymptotes. Okay, I can take all the x but not the x asymptotes. And y belongs to what? Y belongs to r except -3. And everything y can be anything else but not -3. So that's what I'm going to ask you to do. So all the graphs we sketch, write that x belongs to, y belongs to, talk about the domain and range. And I'll check answer with you next lesson. Please do that. Okay, so it's very important. I should combine this teaching together here, like talk about x and y domain range, but I can't do that at that time. So do the domain range for all the graphs we have sketched, like domain range here, domain range here, and domain range for all these square root. It's very important to think about the square root one. Okay, so the domain range for that. And more importantly is the domain range for circles and semicircles. I'll tell you there's something on the quiz for semicircles and talk about domain range. Okay, so make sure you try to think about how to find the domain range for semicircles, full circles. Okay, we'll go through that next lesson. Well, for example, I just show you one. So for that semicircle, okay, for that semicircle, the domain, if you can see the domain is from the left to right. What's the furthest left point you can reach and what's the furthest right hand side point you can reach? So the domain will be -4 to 2. It is the domain. And the range is you from the bottom to top. What's the lowest point you can get and what's the highest point you can get? So the lowest point is -1 and the highest point is 2. So that's how you find the domain and the range. Okay, so make sure you talk about the domain range for each individual graph, and we can check answers next lesson. And your quiz will be Monday if I have class on Monday. Okay, that's it for today.